So guys, in today's video we are going to study about the structure of the carbonyl group. It is very important to know the structure of the carbonyl group in order to predict the products. You'll come to know why I am saying this when I will refer to certain reactions in this chapter. So while going with this concept, of course, I would like to ask you, if I will say you to write a carbonyl group, how you're going to write it? Of course, I will write a C. I will write double bond with oxygen and two other bonds. Yes. So here we are going to study what type of a hybridization whether this carbon is undergoing. Do remember guys, first important point we have to remember in the structure of the carbonyl group is that the carbon in a carbonyl group, is sp2 hybridized. What it is? It is sp2 hybridized. First important part one has to know. Now I will ask you the second question. What is that? That means when it is carbon is having an sp2 hybridized orbitals, it is specifying total number of hybrid orbitals is how much? What are the total number of the hybrid orbitals present? Of course, 1s, 2p. So there are 3 hybrid orbitals. 3 hybrid orbitals. Very much important to know this. Do remember, carbon utilizing these 3 hybrid orbitals, it forms 3 sigma bonds. Getting my point? So first what we came to know, the carbon in the carbonyl group, that is this carbon in the overall carbonyl group is what type of hybridization? It is an sp2 hybridized. So of course when we are having an sp2 hybridized means there are totally 3 such hybrid orbitals. Alva, 3 sp2, 3 sp2, 3 sp2. Another artha ಏನು 1 sp2, 1 sp2, ಇನ್ನೊಂದು sp2. So like that, how many are there? 3 sp2 hybrid orbitals are present. So what we came to know, utilizing all those 3 sp2 hybrid orbitals, our carbon is forming a 3 sigma bonds. Of course, we can see in the structure. Let me write it once again for you. So this is my carbon. Yes. So utilizing one sp2 hybrid orbital, it forms a sigma bond with oxygen. Yes. And another 2 sp2 hybrid orbitals will be utilized to get bonded with your alkyl or an aryl system. Is that okay? But we know that when I am seeing the carbonyl group, along with a sigma bond, I am having one more bond. Where does this bond is coming from is the question. Remember guys, so that carbon, the carbon in the carbonyl group, it is also having one unhybridized pz orbital. Can you see part? What it is having? It is unhybridized. This orbital is not undergone hybridization. This is having a different energy when compared to these 3 sp2 hybrid orbitals. That is the reason it is called as what? Unhybridized. So, utilizing this unhybridized pz orbital of your carbon, it is going to overlap sideways with the pz orbital of your oxygen. Getting my point? Once again I am saying, whatever the another bond we are seeing over here, I am explaining this bond now. So how it is formed? The unhybridized pz orbital which is present on the carbon, it is overlapping sideways. It is overlapping sideways with the pz orbital of the oxygen. So what you can say? Yes. So whenever there is a sidewise overlap, what type of a bond it is going to exist? Very good. So you will be having a pi bond existence. So one will be a sigma bond, another will be our pi bond. These two will be what? Sigma bonds. Getting my point? So in the carbonyl group we are finding 3 sigma bonds and 1 pi bond. And how does this pi bond is existing? By the sideways overlap of your unhybridized pz orbital of your carbon and the pz orbital of our oxygen. And do remember, this oxygen is also having two lone pair of electrons. What I am saying? Two, see the spelling of lone, L-O-N-E. It is not L-O-A-N. Or it is L-O-N-E. Two lone pair. I am saying as what? Pair of electrons. So totally there are 4 such electrons. Simply I am saying what? Two lone pair of electrons. So this is the general structure of our carbonyl group. So what we are seeing, when we are seeing with respect to the electron density, very good. That is, this carbon, yes, the carbon, whatever the 3 parts are, that is the 3 groups which are attached to the carbon, they all lie in a single plane. So if I consider this page, your carbon, oxygen and the other 2 groups will be lying on this page itself. Whereas, do remember, whereas the pi electron clouds, that is these, the pi electron clouds will be lying, one will be above the plane, another will be below the plane. Are you getting my point? Why I am saying this? Because certain cases it will be very important to know these concepts. So first and the foremost thing what we came to know is the carbonyl carbon is sp2 hybridized. Okay, so sp2 hybridized means it will be having 3 sp2 hybrid orbitals. So utilizing all the 3 sp2 hybrid orbitals, it is going to form 3 sigma bonds that we have seen over here. Then utilizing an unhybridized pz orbital of the carbon, it is going to overlap with the pz orbital of the oxygen sideways, resulting in the formation of the pi bond. But when we are considering its electron density, we came to know that carbon, oxygen and the other 2 groups that are attached to the carbonyl carbon, they are lying on the same plane. Because it is undergone sp2 hybridization, it will be lying in the same plane. Whereas here itself we can see, if we do not know the plane and consider madre, if like this was a plane, so ಈಗ sideways overlap ಆಗ್ತಾ ಉಂಟೆ ಅರ್ಥ ಏನು, electron density will be ಒಂದು above the plane ಇರುತ್ತೆ, ಇನ್ನೊಂದು below the plane ಇರುತ್ತೆ ಅಲ್ವಾ. ಇದು ಯಾವ್ದು electron cloud? Pi electron cloud. So ಆ reason ಇಂದ ನಾನು ಹೇಳಿದ್ದು, the 3 groups attached to the carbon will be on the plane, whereas the pi electrons cloud will be one above the plane and another one below the plane. Is that clear? Very much important concept. First and the foremost thing, you have to remember that what type of a hybridization your carbonyl carbon is undergoing. And the second most important thing you have to remember, what are the total number of the sigma bonds they will be having and what is the total number of pi bonds they would be having. Is that clear? Can we move further? Okay. So when I'm seeing a structure, remember the bond angle which is resulting is nearly 120 degree. Nearly equals to that of your trigonal planar. Okay. But the major important task what we have to remember over here is we want to know the charges on the carbon and that of your oxygen. Alva. So do remember when we see the electronegativity values of your carbon and oxygen, of course we know that your oxygen is what? Somewhat highly electronegative. So therefore what would be happening? Very good. This pair of electrons will more be associated with respect to that of your oxygen. So when we are seeing the resonance structures, we are seeing in this way. If I take, I would be getting like this. That is, O will be having a negative charge, whereas your carbon will be having a positive charge. It is main reason is because of the electronegativity difference between that of your carbon and the oxygen. Therefore we say that your carbon will be an electrophilic over here. Carbon will be an electrophilic, whereas our oxygen will be a nucleophilic. Nucleophilic, or in simple words we say them as Lewis acid. Lewis acid. This one has a Lewis base. Lewis base. So that is in the need of electrons. As is the reason it's called as a Lewis acid. It is in the what you can say. It is in the part of donating the electrons. It is having a concept of Lewis base. So why I'm saying this? Because this is the important concept for us. For example, if a nucleophile is coming and attacking, of course there will be a question, where does it go and attack? Of course it will come and sit on the carbon. Why is it so? Because when we are seeing the structure of the carbonyl group, due to the electronegativity difference between carbon and oxygen, we could see that carbon is having a positive center. Remember, this plays a vital role when you're going to study certain reactions, which will be coming later in these videos. Is that clear? Okay, once we have come to know the structure of the carbonyl group, the next part we are going to see is called as preparation of aldehydes. Preparation of aldehydes. Very much important, because all the preparations, okay, in this video I'm just covering only 2 preparations, but remember, both the preparations are named reactions. So I have mentioned earlier itself, whenever a concept of named reactions arises, it is very much important, both in the point of your exams and also in the point of view of your competitive exams too. So please pay attention when we are dealing with this concept. Okay, so next concept what we are going to deal is called as what? Preparation of aldehydes. So guys, first let us see the first important preparation. That's a named preparation which is called as Rosenmund reduction. Rosenmund reduction. So basically, in this reaction, of course it is giving us a hint that it is a reduction reaction. Okay, so what is happening over here? First let us understand. So basically, in this reaction we are going to see that how one can convert acyl chloride, or it is also called as acid chloride. Yes, acyl chloride or acid chloride to aldehyde. Very much important. So this is a general brief note we can give about Rosenmund reduction reaction. So how can we write? If I want to write acyl chloride, very good. That is RC double bond O Cl. Please make a note over here what I'm writing. Okay, RCOCl is a general representation of our acid chloride or acyl chloride. So when this acyl chloride is heated with hydrogen. Got the word why we have used reduction over here? Because we are supplying hydrogen over here. It's an addition of hydrogen reaction. So what has happened? So when acyl chloride is heated with a hydrogen, this is very much important, in the presence of palladium catalyst, PD, in the presence of palladium catalyst, do remember, which is supported over barium sulfate, This is very much important to note this. Okay, so when acid chloride or acyl chloride is heated, mark my words, is heated with a hydrogen in the presence of palladium catalyst, which is supported over barium sulfate, aldehydes are obtained. So what you're going to get? Aldehydes plus HCl. So this reaction will be called as Rosenmund reduction reaction. In PU exams, they can ask you directly, give a note on the Rosenmund reaction, or they can twist the question. What is that? How can you prepare? Please mark my words. How can you prepare aldehydes from acid chloride? I repeat, how can you prepare aldehydes from acyl chloride or an acid chloride? So you should switch your mind directly to this reaction, that is your Rosenmund reduction reaction. So now let us take some examples. Let us substitute some alkyl groups and the aryl groups for our R. So what is the formula for acetyl chloride? Yes. So CH3 C double bond O Cl. Alva. This is called acetyl chloride. Acetyl chloride. Getting my point? See, in these cases we are observing, nowhere they are using the IUPAC name. Most of the cases they will be using the common name itself. So in aldehydes, ketones and carboxylic chapter, it is very much important to know their common names also. Okay. So when your acetyl chloride is heated with hydrogen, mark my words, when acetyl chloride is heated with hydrogen in the presence of palladium catalyst supported over barium sulfate, what aldehyde you are going to get? Acetaldehyde is obtained. Acetaldehyde is obtained. So this is called as what? Acetaldehyde. Alva. So how I have derived this name acetaldehyde? In case if it was, it's normal ಆಗಿ ಯಾವ ತರದ ಆಸಿಡ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಬಹುದು, ಈ COH ಬದಲು COOH ಹಾಕ ಏನ್ ಸಿಗುತ್ತೆ ನಮಗೆ? ಅಸಿಟಿಕ್ ಆಸಿಡ್. ಸೊ ಆ IC ಆಸಿಡ್ ನ ತೆಗೆದು ಅಲ್ಲಿ ನಾವೇನ್ ಆಡ್ ಮಾಡಬೇಕು? ಆಲ್ಡಿಹೈಡ್. So it will be called as what? Acetaldehyde. Okay. If I am going to choose now C6H5COCl. So what this is called as? Remember, very much important. Why I am going to say? It is called as what? Benzoyl chloride. What it is? Benzoyl chloride. Because when we write C6H5CH2Cl, remember it is called as what? Benzyl chloride. What it is called as? Benzyl chloride. Are you able to make a difference? So it is zoyl. When it is coming, when benzene ring is having a COCl group. But when a benzene ring is having a CH2Cl group, it is called as zyl. Benzyl. Whereas COCl is called as what? Benzoyl. Okay. So when benzoyl chloride is heated with a hydrogen in the presence of palladium catalyst supported over barium sulfate, so what you are going to get? C6H5CHO. What it is? Benzaldehyde. So benzaldehyde, very much important reaction, plus HCl. So in either ways they can ask you guys, how can you prepare benzaldehyde from benzoyl chloride? How can you prepare acetaldehyde from acetyl chloride? Or direct questions they can ask. Can give a brief note on Rosenmund reduction reaction. I am repeating again and again in my organic chemistry videos. In your PU board exam, whenever they are asking you to write a reaction, first you write the reaction in theoretical part. That is how when acyl and acid chloride is heated in the presence of a palladium based barium sulfate catalyst, aldehydes are obtained. First you write it and then you write the reaction. If you write only reactions, your half of the marks will be deducted. Again and again I am saying it. Whenever they are asking you to write a reaction, first you write the reaction in words and then you write the reaction in its formula wise. Is that clear? Okay. No doubts. Can we move further then? Okay. So this was the first important reaction in the preparation of aldehydes, which is a named reaction which is called as what? Rosenmund reduction. Why it is called as a reduction? We could see that here acid chlorides have been treated with what? Hydrogen. Since we are supplying a hydrogen, so it is a reduction reaction. Okay. And the catalyst which is supported over, there is a palladium catalyst supported over barium sulfate, must and should be there in this reaction, because it is acting as a, what you can say, it is promoting as a catalyst, a heterogeneous catalysis for this hydrogen to come and sit and to carry out the reaction further. Clear guys? No doubts? We'll move further then. The next important reaction we are going to study, which is also an, what you can say, a named reaction, which is called as Stephan reaction. Stephan reaction. So basically in Stephan reaction, we are going to prepare the aldehydes from nitriles. What is that? From nitriles. So Stephan reaction is a reaction in which we are going to convert our nitriles to aldehydes. So let us see how it is being carried out. So of course now what is the formula for nitriles? General formula is RC triple bond N, which is also called as what? Cyanohydrocarbons. Generally they are called as what? Nitriles, or they are also called as what? This is what a cyano group, which has been attached to a hydrocarbon. So cyanohydrocarbons. But generally we use the word as nitriles. What it's called as? Nitriles. So when these nitriles are reduced in the presence of stannous chloride. Mark my words, I'm not saying as a stannic, it is stannous Okay, stannous chloride in the presence of a hydrochloric acid. Remember, first it gets converted to an imine group. What is that imine andre? RCH double bond NH. ಇದು ನೈಟ್ರೈಲ್ ಆದ್ರೆ ಫಸ್ಟ್ ಅದು ರಿಡಕ್ಷನ್ ಆಗಿ ನಿಮ್ಗೆ ಏನ್ ಕೊಡುತ್ತೆ? ಇಮೈನ್ ಕೊಡುತ್ತೆ. Then followed by acid hydrolysis. H plus in the presence of water, we are going to get RCHO plus NH3. ಹೇಗೆ ಸರ್? ನೋಡಿ, ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ಕೊಡ್ತೀನಿ. ಹಾಕ್ತಾ ಇರೋದೇನಿಲ್ಲಿ H2O ಅಲ್ವಾ? ಜಸ್ಟ್ ಯು ರಿಮೆಂಬರ್, ಇಲ್ಲಿಗೆ ಏನಾಗುತ್ತೆ? O ಬರುತ್ತೆ. ಅದೇ ಇಲ್ಲಿಗೆ ಏನ್ ಬರುತ್ತೆ? H2 ಬರುತ್ತೆ. ಅವಾಗ ಇದೇನಾಯ್ತು? RCHO. This will be what? NH3. Don't write like this in your exam. I'm just giving you so that you can remember this. How to remember the products. So ಏನು ಸ್ಟೀಫನ್ ರಿಯಾಕ್ಷನ್ ಅಂದ್ರೆ? So it's a reaction in which nitriles are reduced. Very much important. Mark my words. Nitriles are reduced in the presence of stannous chloride and hydrochloric acid. In the presence of stannous chloride in a hydrochloric acid to give imine. First ನಿಮಗೆ imine ಬರುತ್ತೆ. Then on acid hydrolysis, okay, acid hydrolysis of this imine gives us what? Respective aldehyde plus ammonia. So this is called as what? Your Stephan reaction. Very much important. You could just note that this is also a reduction reaction. ಯಾಕೆ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತ ಹೇಳ್ತಾ ಇರೋದು ಅಂದ್ರೆ, Rosenmund ಅಲ್ಲಿ we are preparing the aldehyde from acyl chloride or acid chloride. Whereas in a Stephan reaction we are converting the nitriles to our aldehydes. Two different reactants we are taking over here and we are getting the same type of a product, that is your aldehydes. Is that clear? Let us have certain examples regarding it. So let me take the first example as CH3 C triple bond N. Yes, what is called as ethane nitrile. So of course now when it is reduced in the presence of stannous chloride in HCl, yes, so first I am going to get an imine, that is I am going to get as what? CH3 single bond CH. ಏನಾಯ್ತು? ಈಗ ಒಂದು ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗುತ್ತೆ. ಯಾಕೆ? ಇಲ್ಲಿಗೆ ಒಂದು ಹೆಚ್ಚು ಬಂದು ಅಟ್ಯಾಚ್ ಆಯ್ತು, ಇಲ್ಲಿಗೆ ಒಂದು ಹೆಚ್ಚು ಬಂದು ಅಟ್ಯಾಚ್ ಆಯ್ತು. ಸೊ ಡಬಲ್ ಬಾಂಡ್ NH. ಸೊ ಇದನ್ನ ಏನ್ ಮಾಡ್ತೀನಿ ಈಗ? ಆಸಿಡ್ ಹೈಡ್ರಾಲಿಸಿಸ್, ದಟ್ ಇಸ್ H ಪ್ಲಸ್ ಇನ್ ದಿ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ವಾಟರ್. ಸೊ ಅವಾಗ ಏನಾಯ್ತು? ಇಲ್ಲಿಗೆ O ಬರಬೇಕು, ಇಲ್ಲಿ ನಂಗೆ H2 ಬರಬೇಕು. ಸೊ ವಾಟ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್? ಎಸ್, CH3 CHO plus NH3. Are you getting the difference? So in the first case, Rosenmund ಕೂಡ ನಾನು acetaldehyde ನ ಪ್ರಿಪೇರ್ ಮಾಡಿದ್ರೆ that was from acetyl chloride. ಇಲ್ಲೂ ಕೂಡ ನಾನು acetal aldehyde ನ ಪ್ರಿಪೇರ್ ಮಾಡಿದ್ರೆ ಆದ್ರೆ from ethane nitrile. Why I am giving the specifications again and again? Because in competitive exams they will be not giving in like this. Instead they will be giving you this way. CH3 C triple bond N in the presence of stannous chloride and HCl gives you A, whereas this A on acid hydrolysis gives us B. Identify your A and B. They will be given a 4 options. So first you have to understand, first it is going to get converted to respective imine, and that imine on acid hydrolysis gives us the respective aldehyde. ಅದೇ ನಿಮ್ಮ Rosenmund reaction ಯಾವ ತರ ಕೊಡಬಹುದು ನಾನು? CH3 C double bond O Cl. Directly they will be giving you as whatever palladium based barium sulfate catalyst gives you B. In both the cases B are same. Identify the product. So you should come to know, okay, first reaction was the preparation of aldehydes from nitrile, whereas the second reaction is preparation of the aldehyde from acetyl chloride. So this is what Rosenmund. Okay, B andre ಎರಡಲ್ಲೂ ಒಂದೇ ಬರ್ತಾ ಉಂಟು. ಹಾಗಾದ್ರೆ ಏನಿದು? This is coming under the concept of preparation of aldehydes. So in this way you have to judge your question answers when you are trying for your competitive exams. Is that clear? Pure board exam, there is a chance they can ask you directly, or there is a chance that they can ask you separately, but they will never ask you in both in the, as I have asked over here. But in competitive exams, they will merge these two. Why? Because both the products are same, but the method of getting them is different. In order to confuse you, or in order to know that how much you know, they can give such tricky questions. So first and foremost thing, whenever you're reading an organic reactions, you should pay attention. What are the reactants? What are the reagents? And what type of a product we are going to get? And you have to relate those products. Ade product adu bere kade bandidya nodbeku ನೀವು. Okay? So this is the way of understanding our, what you can say? Yes, organic reactions. Is that clear? No problem? Very good of that. Remember guys, now I'm going to give an additional information, very much important point of your competitive exams. So here, as we have used stannous chloride in the presence of HCl, they can also use a compound which is called as dibol H. What it is called as? Dibol H. What is the full form? Remember, it is called as di. Di, I stands for isobutyl. I stands for iso, B stands for butyl, aluminium. Aita? So D stands for di, I stands for iso, B stands for butyl, Al stands for aluminium. All the letters are capital. Okay? Dibol H means it is hydride. So why I'm saying this, because in your competitive exams, by utilizing your nitriles, they are going to get aldehydes. But what they will do, instead of taking your stannous chloride in HCl, they will prefer dibol H. What is the reason? I will say. Of course, in this reaction, what we came to know, the triple bond has been converted to double bond in this Stephen reaction. But when the question arises, for example, CH3, CH, double bond, CH, single bond CH2, single bond C, triple bond N. Okay. And I'm going to reduce it to H. So now the question arises, of course, ಇಷ್ಟು ಪಾರ್ಟ್ ನಂಗೆ ಏನು ಆಲ್ಟರ್ ಆಗಬಾರ್ದು, ನನಗೆಲ್ಲ ಆಲ್ಟರ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಇಷ್ಟು ಪಾರ್ಟ್ ಮಾತ್ರ. ಅದು ಆಲ್ಟರ್ ಆಗಿ ನಂಗೆ ಏನ್ ಕೊಡಬೇಕು? ಆಲ್ಡಿಹೈಡೇ ಕೊಡಬೇಕು. ದಿಸ್ ಇಸ್ ದಿ ಒನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಸ್ಕ್. ಸೊ ಫಸ್ಟ್ ಏನ್ ಹೇಳ್ತಿದ್ದೀನಿ ನಾನು, ದಿಸ್ ಬಾಂಡ್ ಶುಡ್ ನಾಟ್ ಗೆಟ್ ಆಲ್ಟರ್ಡ್. ವಾಟ್ ಎವರ್ ದಿ ಡಬಲ್ ಬಾಂಡ್ ಇಸ್ ದೇರ್, ಇಟ್ ಶುಡ್ ಬಿ ದೇರ್. But when I choose my stannous chloride in a HCl, it is that much strong that it can even reduce this double bond to single bond. Are you getting my point? So we have to use certain other things or other reagents. So in that scenario, what I do, instead of using the stannous chloride in a HCl, I utilize my dibol H. So instead of your stannous chloride, I am going to use my dibol H. So when I am using the dibol H, what it is going to do, it is only going to reduce your nitrile group, and it is having no effect on this C double bond C. So what is the type of a product you are going to get? Ultimate product after acid hydrolysis. Remember, after acid hydrolysis also I am saying, of course, first ಏನಾಗುತ್ತೆ, imine convert ಆಗುತ್ತೆ ಇಲ್ಲಿಗೆ. ಅದನ್ನ imine ನಾನು acid hydrolysis ಮಾಡಿದಾಗ you just see CH3, CH, double bond CH, single bond CH2, single bond CHO plus NH3. So what is the main important of this dibol H is, remember, it is only going to reduce polar multiple bonds. It is only going to reduce polar multiple bonds. I am telling you the advantage of this dibol H. It is only going to reduce what? Polar multiple bonds. And do remember, it is not going to reduce non-polar multiple bonds. ಹಾಗಂದ್ರೆ ಏನು ಸರ್? Of course, polar ಅಂದ್ರೆ ಎಕ್ಸಿಸ್ಟ್ ಆಗೋದು ಯಾವಾಗ? whenever there is a higher electronegativity difference. ಅದು ನಾವಿಲ್ಲಿ ನೋಡ್ತಿದ್ವಿ ಕಾರ್ಬನ್ ಮತ್ತೆ ನೈಟ್ರೋಜನ್ ಮಧ್ಯೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಒಂದ್ರ ಮೇಲೆ ನೆಗೆಟಿವ್ ಬರುತ್ತೆ, ಒಂದ್ರ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ. ಆದ್ರೆ ಇಲ್ಲೇನಾಗ್ತಾ ಉಂಟು, ಬೋತ್ ಆರ್ ದಿ ಸೇಮ್ ಆಟಮ್ಸ್. ಸೊ ಅವಾಗ ಏನಾಗಿರುತ್ತೆ, ಇದ್ರ ಮೇಲೆ ಯಾವ ತರದ್ದು ಪೊಲಾರಿಟಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗಲ್ಲ. ಸೊ ಯಾವಾಗ ನಾವು ಡೈಬೋಲ್ H ನ ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ, ಇಟ್ ಇಸ್ ಓನ್ಲಿ ಗೋಯಿಂಗ್ ಟು ರೆಡ್ಯೂಸ್ such polar multiple bonds, and this is not going to reduce our non-polar multiple bonds, that is this bond. So that is the reason whenever we are using the dibol H in the reduction of your nitriles, it is only going to reduce your nitrile group and not that of your C double bond C or your multiple bonds. Is that clear? This is a very much important point one has to remember in your organic reactions, because in competitive exams the main reactions will be depending upon such reagents. ಇದನ್ನ ನಾವು reagents ಅಂತೀವಿ. ಸ್ಟೇನಸ್ ಕ್ಲೋರೈಡ್ HCl ಕೂಡ ಒಂದು ರಿಯೇಜೆಂಟ್. ಅದು ನಾವು ನೋಡಿದ್ವಿ ಏನು, ಅಲ್ಲಿ ಎಲ್ಲರೂ ಡಬಲ್ ಬಾಂಡ್ ಬಂದಿದ್ರೆ ಆ ಡಬಲ್ ಬಾಂಡ್ ನ ಒಂದು ರೆಡ್ಯೂಸ್ ಮಾಡಿ ನಮಗೆ ಆಲ್ಕೇನ್ ಕೊಡೋ ಸಾಧ್ಯತೆಗಳಿತ್ತು. ಆದ್ರೆ ಆಗಬಾರ್ದು ಅಂದಾಗ ನಾವು ಏನ್ ಮಾಡಿದ್ವಿ, ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಯೂಸಿಂಗ್ ಸಚ್ ಅ ಸ್ಟ್ರಾಂಗ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್, ಐ ಹ್ಯಾವ್ ಯೂಸ್ ವಾಟ್, dibol H, which is only having the effect on the polar multiple bonds and not on that of your non-polar multiple bonds. Is that clear? So in today's video, we came to know about the structure of the carbonyl group, and there we came to know that the carbon in the carbonyl group is an sp2 hybridized, where it is having such 3 sp2 hybrid orbitals. Utilizing the 3 sp2 hybrid orbitals, it is forming a 3 sigma bonds, and remaining 1 unhybridized pz orbital of the carbon, it's overlaps sideways with the pz orbital of your oxygen, resulting in the formation of our pi bond. Is that clear? Coming with respect to its planarity, we came to know that whatever the 3 atoms which is attached to that of your carbonyl carbon lies in a single plane, whereas the electron clouds of your pi bond, the electron clouds of our pi bond exist above and below this plane. Alva, above and below this plane. Coming with respect to its resonance structures, we came to know that your carbon is having a slight positive charge and that of your oxygen is a slight negative charge, leading to the polarity. So therefore the carbonyl carbon will be acting as a Lewis acid, as an electrophilic center, whereas that of your oxygen will be having a nucleophilic, acting as a nucleophilic, and as that of your Lewis base. Very much important. Again and again I'm mentioning, the carbonyl carbon is undergoing sp2 hybridization. Then we came to know an important part, a concept, we can say preparation of aldehydes. In today's video, we are mainly dealing with the 2 important preparations, that is also named reactions. One is called as a Rosenmund reduction reaction, another is your Stephan reaction. Yes. So of course in the Rosenmund reaction, we came to know that it's a conversion of your acyl or acid chloride to aldehydes. How we are going to convert it? When acyl or acid chloride is heated with a hydrogen in the presence of palladium catalyst supported over barium sulfate, aldehydes are obtained. Okay. But when coming with respect to the Stephan reaction, it was a reaction in which we are converting our nitriles to first imine, and then on acid hydrolysis of the imine, we will be getting our aldehyde. But before the conversion of the imine, what we have to do, nitriles has to be treated with stannous chloride in concentrated HCl. Very much important. Nitriles has to be treated with the stannous chloride. Very much important. Again I am saying it is stannous chloride. It is not stannic. It is stannous. Yes, which is having what charge? +2 charge. Very much important. Stannically +4 barutte. Okay. Stannous and +2 charge it is having. There is a reason I am saying again and again. It is stannous chloride. Okay. So when nitriles are reduced in the presence of stannous chloride in a concentrated HCl, imines are obtained. On acid hydrolysis of imine, we will be getting our respective aldehyde. An important reagent we came to know today, which is called as what? Dibol H, which is going to be also used in our Stephan reaction. What is the main tendency or what is the main advantage of this dibol H? Basically, it is only going to reduce the polar multiple bonds and it is having no effect. I repeat once again, it is having no effect on this non-polar multiple bonds. And what is the full form of a dibol H? D stands for di, I stands for iso, B stands for butyl, Al stands for aluminium, H stands for hydride. So there comes your name, dibol H. And remember, all the letters are capital. We are not going to use these small letters over here. All are caps. An important reagent which is having an impact only upon the polar multiple bonds and not on the non-polar multiple bonds. And we also see an example over here. That is how you can see that when you are getting the final aldehyde, of course only the nitrile group has been reduced and not your non-polar multiple bond. That is as it is remained in our final product. Okay, please note it down. Very much important in point of your competitive exams. So in our next video we are going to see the another two important preparations, which is also a named reaction. Along with that, I'm also going to give certain additional information. Okay,